All right. So I'm gonna talk about last year. You were talking about concavity, but I'm gonna talk about concavity a little bit different. Um, so let's just say this function like this, and this is f of x. Now I'm gonna draw a tangent line everywhere. I'm gonna draw a tangent line. I'm gonna teach you how to draw a tangent line. It's like imagine that you are, just draw a point at that particular point like this, and you're gonna draw a tangent line. It means like it looks like this. Sorry, let me look. It looks like this is a point here, and the tangent line is gonna be this. If a tangent line is above, and this is a very, very important idea. I know Kench says smile face and sad face, and I know Mr. Ollie says something else. I don't remember what Mr. Ollie says. For Kench, right? Yeah, he says something like the sad face concave down and happy face is concave up. I don't know what Ollie told you though. What did Ollie tell you? Anybody have Ollie last year?
Yeah, but like, he didn't really say I have a saying. He said it
yeah. Okay. Well, for this point, like for calculus, I need you to understand the tangent line because tangent line is what's important. So imagine if I draw a tangent line on this point. See that tangent line is above x-axis. Anytime you'd have tangent line above x-axis, even though smile face and sad face are easier way to determine, I still want you to see the tangent line because some type of question on justification on AP exam, they require you to do tangent line, understand the tangent line ideas. And tomorrow we will give you a demonstration of tangent lines important. So you see that tangent line still above. Somewhere around here, you cannot know, like this point here, like this region here, right? You don't know tangent line is above or below anymore. Because that's where the inflection point it actually happened. Now, when you get below that, so I'm going to use a blue part. So this part is going to be, see the tangent line is obviously below now. Tangent line is below, tangent line is below, and tangent line is below. So if a tangent, sorry, if tangent line is above the curve, then it's concave down. If a tangent line is below the curve, is concave up. Now, where this point right here is when you tangent line is exactly on the line, they are more likely is where the concavity changes, which is we know is inflection points. And I draw a cross here because later we're gonna use cross to represent inflection point. This is where concavity change. Because if you draw a tangent line, you don't know if it's on the top or on the bottom. If I draw a tangent line here, you don't know it's on the top or bottom. That's the region where it's more likely the inflection point is going to happen. Any questions? Just make sure it's recording. All right, got it. Now, what we're going to do is we're going to go in to really think about graphing this function, and we're going to try a function. Oh, well, we're going to talk about concavity first. So we already did talk about concavity, but what's that got to do with calculus, right? The calculus says if you have f double prime of x is greater than 0, is concave up. Which kind of makes sense. Up, positive, yeah. f double prime of x is less than 0, it's concave down. Then there's a possible inflection point. The possible inflection point is f double prime of x is equal to 0, or f double prime of x is equal to undefined. Just like critical number, but second derivative. Is that okay? Notice a possible inflection points. Now, in order to justify, you need to do a number line test first. Number line test first. If I do a number line test first, then you can see which region is positive, which region is negative, which region is concave up, which region is concave down. Now, in order for you to justify this inflection point, justification for inflection point, and I want to review again. I want to review a very, very general things again. Hopefully you're sharing.
For my girlfriend, I just want one.
So you're gonna steal one from your girlfriend? Okay. What is that anyway? What is that?
You want one?
No. It's your girlfriend. I don't want to take it from your girlfriend. All right, justification for inflection point. This one you're gonna say, well, f double prime of x change from positive or to negative, or negative to positive at x equal to c. Therefore, f of c comma f of c is equal to inflection points. So if you want to justify, if they say, hey, where's the inflection point? You can say x equal to 2. But how do you justify? You're going to say, well, f double prime of x changing from positive to negative or negative to positive at x equal to 2. Therefore, 2 comma f of 2 is an inflection point. Just like maximum. Maximum, you're going to say, hey, if it's a maximum, it says f prime of x changing from positive to negative at c. Therefore, c comma f of c is relative maximum. Now, if I ask you to justify absolute maximum, what do you have to do? Absolute maximum you have to do is a table. Yeah, you have to do table. So there's 3 type of justification. Absolute maximum and min is a table. I'm gonna say that again. Relative maximum min, you're gonna say f prime of x changing from positive to negative or negative to positive. Inflection point, you're gonna say f double prime of x changing from positive to negative or negative to positive at particular c. So there are 3 different justifications you need to do on AP exam. If you know how to do those, you don't have to do too much math. I promise you don't have to do too much math to get a 3 or 4. Because you just have to be able to explaining things. Then there's a good 20% of the test just explaining things. So it's not even about math. All right. We're going to start with this question. So the question we're going to start is, this question looks like this. It's a little bit complex, but I'm going to ask you to define a couple of things. So f of x equal to 6 over x squared plus 3. In this particular case, I want you to find f prime of x. And I want you to do a number line test, and I want you to find double prime of x and do a number line test. But you got to check each other what's your first derivative and what's your second derivative. Also, knowing when to avoid quotient rule. 3 situations you should avoid quotient rule. I'm going to mention again. If you have constant on the top, if you have constant on the bottom, or you have monomial on the bottom. So there were 3 situations. Now this is one of the situations, constant on the top. What can I do here instead of using quotient rule? It doesn't mean that use quotient rule is wrong. I just feel like it's a slightly more complicated. Yes.
You can change the denominator and put it to the negative power.
Yes, that would be a good idea. So I'm going to write it down. Says what Emily suggested says 6x squared plus 3 to the negative 1 power. Now take a derivative there just require chain rule rather than quotient rule. Could you done quotient rule? Could you get same answer? Yes, you're going to get absolutely same answer. I just don't think it's efficient. Learn how to manipulate things and to take a derivative. I think it's a little bit better. Now I'm going to take a first derivative here. It's 6, right? Negative 1 x squared plus 3 to the negative 2. What else I'm forgetting? 2x. Don't forget the 2x. So that's going to be negative 12x over x squared plus 3 to the square. I rewrite like this way. I can do a number line test here. What's my critical number here? It's just 0. It doesn't have anything else. Because x squared plus 3 is an imaginary number if you try to solve for that. So negative 12x, that's it. X squared plus 3 to the square. This is always positive. It doesn't even need a test. This one actually end up to be positive. This one's actually end up to be negative. So it's positive, negative. So it's increasing, decreasing. So 0 must be what? Is what? Relative maximum. So this is relative maximum. And then it's going to be 0 comma what? What is 0 comma what? 2, because f of 2 is equal to 6 over 0 squared plus 3 is equal to 2. So 0 comma 2. That's a relative maximum. Now let's take a second derivative. Now this one you need to use quotient rule, unfortunately. So let's try see if you can do quotient rule correctly.
Wait, Mr. Yu, who are we plugging in?
Original function, because we want to find out what happened in the original function. Where is your maximum located at?
You found? It says what essentially happened. Plug that is what I did. We use chain rule to find what you plugged into.
Anything other than first power is chain rule. Yes.
Wait, so when we you always ignore the imaginator
That's the original.
when we find like the critical.
Okay, I got you.
No, the critical number for this one, if you do the bottom, right? If I just say this is the bottom, x squared plus 3 is equal to 0, x squared equal to negative 3, x equal to square root negative 3 plus minus. That's actually an imaginary number. So you don't need to do the bottom because the bottom is an imaginary number.
If it was negative 3, it would work.
You would a square plus minus square root 3. Yes, you would absolutely work.
Okay.
The x squared plus something is not going to work because there's no critical number there. So there is no critical number. Does that make sense, Miranda?
Yeah.
So if it's x squared plus something, you don't need to worry about it. Now I'm going to take a second derivative. Now this one second derivative is kind of hard, so I'm going to do it with you alone. So that way you don't make mistakes. So we love the low D high minus high D low. I'm going to move this tiny bit. High D low is going to be 2 times x squared plus 3 to the first times 2x. Is that okay? Over x squared plus 3 to the which power? And yeah. So what happened, you see there's a GCF here. There's a GCF, this and this. So I can factor x squared plus 3 out. And I'll even factor 12 out, just makes a little bit easier. So then I will end up to be -1 times x squared plus 3. And then if I factor out 12, it's going to be plus 4x squared, I believe, over x squared plus 3 to the 4th. So if I do the quotient rule here, 3, and this is 1, this is 0. What? This x, and there is a 2, and there's a 2. So it's 4x, and this 2 negative sign becomes positive 4x. So that's going to be 12 times, if I distribute correctly, that's going to be 3x squared minus 3 all over x squared plus 3 to the 3rd power. And you say, oh my God, this is very difficult. But again, the bottom don't need to worry about it because the bottom is imaginary. And just have to worry about the top, which is -1 to 1. And this is 36 times x squared minus 1. If I plug in anything less than -1, it's going to be positive, negative, positive. So it's going to be concave down, concave up, and concave up. That makes, what is a -1 and +1? Inflection point, good. So it's going to be inflection point. Can I find a y value of inflection point? Yeah, I can. Just plug in original function. So f of 1, that's going to be 6 over 1 squared plus 3. That's equal to 6 over 4, which is 3 over 2. It turns out they are even functions, so it's 3 over 2 here, 3 over 2 here. Yes, Miranda?
Is it not negative?
No, it's positive. Because this only part is negative. So negative x squared minus 3 is going to be negative x3 minus 3. So end up with 3x squared minus 3. Uh-huh. What do I do? What?
X squared plus 3. Number 1.
Because x squared plus 3 will result with I. So it's not a critical number. Because you move the 3 to the other side, it's going to be -3. Square root of -3 becomes positive. It becomes complex number. So I have this point, and also I have this one is 3 over 2. So here I also have this point. It's called critical number. I'm not inflection point. I draw a cross. Okay, inflection point. I draw a cross. Also, I want you to know something. Do you know the horizontal asymptote for this case? What is a horizontal asymptote? Max, what is it? 0. So if y equal to 0, I'm going to go sketch it as y equal to 0 is like this. Now, I'm going to look at increasing and decreasing, right? That means I'm going to draw the dotted line here. I'm going to say it's increasing, decreasing, and that's it. And follow the asymptote. Now I'm going to follow the concavity. So the concavity is going to be like this. It's going to be concave up. Is that okay? After you go through the cross mark, it's going to change your concavity. There's cross mark inflection point. So it's change concave down. And after that, it's going to be concave up. And there's an asymptote, so it plateau into that. So that's what's hard. But, yeah. So this is I'm going to give you an easy question. The easy question is x to the 4th. It's a polynomial. 4x to the 3. I'm going to give you some objective for you so that way you know what to graph. One is to find x-intercept. Usually find x-intercept, y-intercept is very important for graphing. The second thing is I want you to find is f prime of x. F prime of x, you can tell me what's increasing versus decreasing. And you can tell me what's the minimum and the maximum. So you can tell me a lot of information about original function, about derivative, The third thing will be double prime of derivative, which is going to tell you concave up versus down. And those are inflection points. So you're going to help me find all those things. You're going to get a head start. I don't know how much time I have. What time we get up? 10:06. Oh, we got a lot of time. So you got 6 minutes to start first derivative, second derivative. Also x-intercept, and then we're going to talk about graphing.
Can you scroll up a bit to show the cavity? It's really
Hannah, to answer your question, x squared plus 3, you don't need to do number line test because it doesn't matter what number you plug in, it's always positive. What'd you say? Square root of negative number. You don't, yeah, square root of negative number is I. Did you find there's a 2 x-intercept? So today's stuff is no different than yesterday. Just do it twice. And the second one just tell you concavity. That's it.
Loved yesterday's.
4x to the third minus 12x squared, I think. And I can factor out 4x squared. This is x minus 3. So again, we set 0 equal to 4x squared times x minus 3. X equal to 0, x minus 3 equal to 0, x equal to 3. And that's the critical numbers. So I'm going to base on that. 0 and 3. And there's a 4x squared. So it doesn't matter what I plug in, it's always positive. X minus 3 is going to be negative, negative, positive. So it's positive, negative, negative, decreasing, decreasing, and increasing. Is that okay? Can you find out what happened in 3 is? Well, 3 is relative what? Can I find the coordinate of the relative minimum? So x equal to 3, so it's going to be 3 comma something. So that means I'm going to plug in the original function, I'm going to plug in 3. What happens if you plug in 3? 3 to the 4 minus 4 times 3 to the third is equal to 81 minus 108. So that's equal to minus 27. Any questions here? Because with maximum, I need to find out where the maximum is, right? Or minimum, I need to find out minimum is, I need to plug in the original function, find out the coordinates. Huh? Yeah. Second derivative. Fairly easy. This is like easy in algebra 1, I think. I swear, the power rule is easier than algebra 1. Oh. So if I factor out 12x, that's going to be x minus 2. Is that okay? That's easy. Just do the thing twice. 0 and 2. And 12x and x minus 2. Negative, positive, positive. And if I were to plug in negative, negative, positive, I think it's positive, negative, positive. This is up, down, and up. How many inflection point are they? 2. Where are they? 0, 0, right? Because we plug in 0. But what about this one? 2 and negative 16. Good. Because f of 2 is equal to negative 16 according to original function. If you don't know, it's going to be 2 to the 4th power minus 4 times 2 to the 3rd power. So that's equal to 16 minus 32, negative 16. Am I did anything that you don't know how to do right now? Everybody got this? The hardest part is to go finding the coordinate. I think that's the highest evaluation. That's actually algebra 2. That part is actually hard. Calculus is actually not too bad. So I'm going to go sketch this graph. I'm going to base on this is a 1, this is 2, and this is 3, and this is 4, and this is 5. And this is negative 1, negative 2, negative 3. I'm going to base on the original x-intercept is going to be this point, and I think 4, that is the x-intercept. I'm going to plug in the inflection point, no, I'm going to plug in minimum. Where's minimum occur? Because original function has a 4, 0 is an x-intercept. And 4 is right here, and 0 is right here. Now, where's the minimum occur? At 3? Okay, so it's at 3 and negative 27. So I'm going to use like this. It's a negative 10. Actually, I'm going to use a little bit. I'm going to use a 4. So this is a negative 10. This is a negative 20. This is negative 30. Is that okay? So at 3, it's going to be negative 27. So it's probably somewhere around here. And it's going to be a minimum. So it's going to be a happy face. W. Kench. I like that guy. He's a good guy. Okay, so what happened at 2? 2 is what? Negative 16, but that's an inflection point, right? There's 2 inflection points. Where did it happen? 0, 0. So I'm going to draw a cross here. A cross here, roughly 16-ish. Those cross going to tell me that the inflection point is going to change. The concavity is going to change. Now, what I would do is I would draw a dotted line here to kind of tell you what the trend of the graph. But we know it's decreasing, decreasing all the way to 3, and after 3 is increasing. So I'm going to just draw it like this. Decreasing, 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 increasing. By the way, you can also tell by M behavior test. M behavior says x to the 4th. It should be limit x approach negative infinity of f of x equal to positive infinity. You should learn that last year. This means the M behavior. This is last year. But again, you don't need it this to last year. We know that this side is up, this side is up if we learned that from last year. Now we're going to follow the dotted line with the concavity. What's a concavity before 0? Concave up, right? So we're going to draw it. We're going to draw concave up. Wait, we're going to the cross sign. If we go to the cross sign, it's gonna change concavity. So it's gonna go down. We see another cross sign is changing concavity, up. But still follow a dotted line. So this is my general graph. So I graph it without Desmos. I actually kind of find out what's going on about the graph. I figure out everything about this graph. I figure out the x-intercept, the minimums, the inflection points, everything, the whole 9 yard. What?
Before the 0, how did you know that the line was?
Because it's decreasing in concave down. Do you see that this is decreasing?
Yeah.
And this is a concave up. Sorry, concave up. I misspoke. So it's decreasing in concave up. So it's like has to be like this. Today homework is not as hard as yesterday. Today is a lot easier, like the first one. So make sure you understand everything.
Whenever I'm pressing out, you look at her and I have
Huh?
This morning I was crashing out, but then I look at her and then she's crashing out and I'm like happy now.
What'd you say, Miranda? I don't have to. I can just look at increasing and decreasing. That still can tell me about everything. Yeah, for first derivative, yeah. So it tells me decreasing, decreasing, and increasing. That should tell me what happened at the end.
Hey, I don't feel too good today. I'm thinking about skipping tomorrow, but
That's fine.
you think like I'm
I'll
gonna miss
record it.
anything important?
I'll record it. You're doing good.
Thank you.
Awesome. Almost touched my eye. Almost.
Maybe not this test. Maybe the test after this.
Almost.
It's kind of hard.
Almost touched my eye. It was like so close. It was like right here.
Like 0.2 points off.
It's like right here.
Yeah. I'm like on the glasses left.
Yes. I don't know why you take the third day off. Well, first of all, your parents told me to take 2 days off. And that doesn't make sense that you guys take 3 days off. I have bunch.
It was the New Year's yesterday, so we had to go to the temple.
I have, but your parents told me Monday and Tuesday.
That was the day in Fifty Valley.